So just a reminder, if you don't have these memorized, you can figure out the sine values, because these are the quadrantal angles, and we need the ordered pair. So at 0, sine is y, which is 0. Then at pi over 2, sine is 1, then 0, then -1, then 0. Right? Yeah. And then how do we find the cosecant? So how do you flip 0? It's something over 0, so that's undefined. If you're going to abbreviate undefined, either UND or UNDF, don't make up your own abbreviations. And then what happens when we flip 1? It's still 1. What happens when we flip -1? It's still -1. So if we had our original sine graph, which I'm going to do, but I'm going to lightly do it and I'm going to dash it because it's not really there. If we have our original sine graph on here, and if I kept that going, follow my pattern, the stuff we were doing last week. What you notice is, excuse me, at pi over 2, we have the exact same answer that we had for sine and cosecant. Exact same answer at pi over 2. So pi over 2, that point is still the same point. After pi over 2, still -1. Like those are the same. And that pattern is going to continue. Every place that it was a 1 or a -1, if you reciprocate it, it's still a 1 or a -1. But what happened when we had 0, 0? What happened at 0 when we flipped it? How do we show undefined on a graph? An asymptote. Exactly. It's going to be a vertical asymptote. So at 0, we're now going to, instead of it being 0 for the value, we now have an asymptote. So I'm dashing these. Every place that it says undefined, I am dashing an asymptote. And then I'm going to continue my pattern, and every place where it was originally 0, it's now an asymptote. Could somebody summarize how far apart those asymptotes are from each other? They're pi apart, exactly. So when we have asymptotes, what's the graph doing? What does the graph do close to an asymptote? It's close to it. Oh, it stops. It's not going to exactly stop. It's going to get closer and closer and closer and closer and closer to the asymptote, but it's never going to cross it, or at least it's never going to cross the vertical asymptote. So what I have on Desmos, and I highly encourage you to use Desmos as well, not as the place to find your answers, but the place to check your answers. What I have on Desmos is a sin x graph. So we can see that original sin x graph. And now what I'm going to do, once I have all eyeballs so nobody misses this, is I'm going to type in cosecant so you can see what cosecant looks like on top of sine at the same time. Are you ready? You ready? You get nervous? Okay. Oops, I typed the wrong thing. Let me change the color. They're both green. That's kind of confusing. We'll do this. And let's make this sign dashed because it's not really there. All right, so there is the cosecant graph. Now you guys told me we have a asymptote at x equals what? Pi was the second one. What was our first one? 0. Okay, I'm going to make that one red. Dashed. And we had another one where x equals pi. Okay. Try to make them all red dashed. Where's there another one? Ooh, Oh, somebody said negative. Is there another one at negative something? It's a lot of asymptotes. Isn't there a line on your paper where you have to like fill in what the asymptotes are? Are there any more? Or is that it? Negative 2 pi. Okay, like this is getting annoying because how many of these am I have to type out? So how many? Infinitely many? Oh, I'm not doing that. So when we go to write, let me draw the graph first. So the graph is, it is getting closer and closer to the asymptotes. It's not going to cross through it. We've got arrows because it goes on forever. Some other things you're going to notice about these is like there's the two pieces, the one up and the one down piece. The one that is up always, always, always connects to the higher point on the sine graph. The one that opens down always connects to the lower point on the sine graph. They won't like open towards each other. They're always open away from each other. So these are pretty easy to graph with the table. It's pretty easy. So now we do have to write down all the asymptotes. So the asymptotes always start at x equals because they are vertical lines. They start at x equals. In fact, they're the x's where in the table the y was undefined. So you guys already listed some of those out to me, but we have to kind of summarize that and make it general so I don't have to write every single one of them. That's too much work. So what is the first lowest non-negative asymptote? Zero. But from 0, I'm going to add on how much each time? Good. But if I write plus pi, is that enough information to give me the answer of 2 pi? Would that give me 2 pi? How many pi's would I have to add on to get me 2 pi? How many pi's would I have to add on to give me 3 pi? So I'm not going to use an x because there's a bunch of x's going on. So we're going to use a k. So I'm going to say by a multiple of pi. So will that work? Will that work for every single asymptote? Could k be -1? What's right? You don't see why not? Could k be a half? What's half of pi? Okay, is there an asymptote at pi over 2? So this is not good enough. Because this is going to give me any number. But I don't have an asymptote at 1/10 pi. So specify what k has to be. We have to specify only what numbers k can be. Whole numbers, the definition of whole numbers is positive. Integers, yes. The word is integers. So I'm going to write, when I use k, I'm going to have to specify that k has to be an integer, where k is an integer. Now, I did not have to use 0. I could have used pi plus k pi, where k is an integer. I could have used -pi plus k pi. It's just, normally this is what people do, is use the smallest one. Also, 0 plus k pi is not, you don't have to have a 0. I could have just written k pi. Okay, but I'm writing it this way just so you, first time you're seeing it. Okay, so now let's see what you can figure out for secant. Because secant and cosine, or sine and cosine are, they look like almost the same graphs. So maybe secant and cosecant almost look like the same graphs. Did anybody graph these last year? Did you graph them in honors? If you didn't. It wouldn't have been a whole lot of time spent on it. Is it okay if you have Desmos open and you're looking at Desmos while we're learning? Totally. Totally fine. That's what I had open a moment ago. Is it okay when you do your assignment that, you know, you do your graph and then you look at Desmos to make sure that it looks right or that your table's right before you actually put it on the paper? Yes, that's okay. When you do stuff and you check stuff, that is your learning experience. That's why I put the reviews up the day before the test. So that you can get on there and check. So what do you do it undefined? So what do you do it undefined? Do it. What do you do it undefined in the graph? What is the next one? Okay, so we're not going to look at that one. Are you waiting for me? Before you do well, if you get erasable markers, I saw she got some. You got one. I saw you had one. I would not have done that until I had the erasable one. So. So once you have your table, when you look over at your table, the undefines are where your asymptotes are going to be. Some of us went ahead and put the cosine graph in because it's the first time that we're seeing secant. Totally fine. You'll see that I'm going to stop putting the original function in when we start doing translations. It's too much. Okay, as you're graphing your asymptotes, you should be thinking, how far apart are they? They are pi apart. So our asymptotes start at, we'll pick pi over 2. That's our starting point. And then we're going to add on, not just pi, but how many pi's? K pi, any value of pi as long as k is an integer. And then if you looked on Desmos or if you remember, like, sine and cosine are almost the exact same. They're just translated 90 degrees. These are going to look the same. If it's an upper point, it's going to open up. If it's a lower point, it's going to open down. We use our asymptotes to get closer and closer and closer. They don't cross through the asymptotes. And we have our secant graph. When you are ready to go on, turn the page.
Yeah.
Okay, so if you think, all right, I'm getting this, start figuring out what transformations are are on number 3 to figure out how to pull out the table. And then I'm gonna jump in and show you what I would do as well, so I can model it for you. Oh no. So this is what I do. So I don't have the cosecant points memorized because I can only handle so much, you know, old lady forget things, right? Just kidding. Not really, but so I just know that cosecant is sine, and I know that my sine values start at 0, 1, 0, -1, 0. So I just kind of like sneak those in there. See where I sneak them in there. Then what I do is I reciprocate those. Oh yeah, sine starts at undefined. Or cosecant. So I didn't give you like a spot to put in the sine function because some of you might easily memorize the cosecant, but I don't. So I know the way that I can retain things the best, and it's putting it on the paper. So I put it on the paper. All right, then we have a 3 in front. And Rachel, do you know what that 3 means?
Yeah.
Vertical stretch by factor of 3. So is that going to go on my x's or my y's? Yeah, because vertical it's going to go on the y's. And the +2, the +2, the +2. Debbie, what's the +2 tell me? Up. So is that going to go on my x's or my y's? Good. Remember, if you've got more than one thing happening, you always want to do multiplication before you do addition. So I need to multiply an asymptote by 3. Okay, so here's an asymptote. I'm just going to draw one up here, and I'm going to describe what's going to happen. We're going to take this asymptote, and we're going to stretch it up and down. We're going to pull it, that asymptote, we're going to stretch it by 3. It's still a vertical line, and vertical lines go on forever. So if I stretch it by 3, it's like the exact same thing. All right, then I'm going to add 2. All right, so this point that was right here is now here. Add 2. It's still that vertical line. And the reason why none of these affect the asymptote, because the asymptotes are x equals. Asymptotes are actually horizontal things, even though they go vertical. Did that confuse anybody? The asymptotes are x equals the equation, so that's why the y transformations don't change anything. So what I do is I just write undefined all the way. And then you guys go and graph this. Some of you have already started. I'm just playing catch up. So at pi over 2, 5, and at 3 pi over 2, -1. So I did not graph my sine function in there. You can, but I did not do it. What I did was graph my my high point and my low point. And if it's the high point, it's going to open up. If it's the high point, it's going to open up. If it's the low point, it's going to open down every single time. So then we can just follow the pattern from there. It's definitely okay. As long as I can see well the final answer, which is not that part of it. And while you are finishing that, I do want to show you with Desmos
the transformations as well. I'm going to get rid of all this stuff that was there. So this is a cosecant graph, and sine x would be its reciprocal. So if I had done 3 sine x, you see how 3 sine x is a stretch? 3 sine x is a stretch from where it was originally. You see that? So if I do 3 cosecant x, now it is as well stretched and connected to those points again. So if I take the sine graph and I add 2, and then I do the exact same thing in the cosecant graph, now they're connected. So it has the exact same transformations as the sine, or the cosecant and sine have the exact same transformations to be connected like that. So if you are trying to graph that sine graph, you have to think about where the sine would be as well. Yeah, they would always connect with the high point and the low point every single time. Okay, so then we have to answer some information. So you're going to have to draw this number. The period, the only thing that changes period would be a horizontal stretch or shrink. And did we have a horizontal stretch or shrink? No. We did not, so what is our period? It's going to be 2 pi. And if you forget, it's horizontally how long is one cycle. So just basically 1 up and 1 down is 2 pi long. Okay. Phase shift is a left or right translate. Did we left or right translate? So none. Vertical shift, up or down translate. We went up 2. Domain we're going to come back to last. Let's skip that baby for a moment. Range. So the range is how far down and how far up. You know what?
No, because it stops.
You have right. It does go from negative infinity to positive infinity, but yes, it's not straight through.
Yeah, because how do you stop so negative 1 and 5? Yeah,
we're going to have to use a union. And this is how I know, and then we're doing range, by the way. I skipped domain. We're doing range. I know how many pieces, because when I look at the range, when I look at up and down, there's 1 piece down here and 1 piece up here. So there's going to be 2 separate pieces with a union. What numbers does it stop and then start again at?
-1 and 5.
And does it equal -1 and 5?
Yes.
So it's going to begin at negative infinity, go to -1, begin at 5, go to infinity. We've got 2 pieces for our range. And remember when we did range with sine or cosine? Like the range of this green one would have gone bracket -1 to bracket 5. It would be everything in between. Now we're everything out between. That was the word idiot. Let's do the asymptotes because I've already showed you how to do those. It's going to be x equals, and then what's the lowest non-negative? 0. So you don't have to write 0 plus. I'm doing it for notes right now, but you don't have to write 0 plus. And then what are we adding each time to get a new k pi? And then you have to say where k is an integer. All right, domain. How far to the left and how far to the right? No, does it go past 3 pi? So how far to the left and how far to the right? Okay, so it goes forever, but does it hit every single x value?
No.
Okay, so then if we're going to do interval notation, we need to have an interval for each piece. So how many pieces are there? Infinitely many?
Yes.
Oh, I'm not going to do interval notation then. Because I would have to do a union between every single piece, and that is a lot of work. In fact, I can't do it because it's infinitely many. So we're not going to write this in interval notation. We're going to write it in a different notation, which is like set notation that says, and you guys are going to help me figure this out. It's every single x except what? If I look here, the blue part is the x's that are graphed. My red asymptotes are where it's not graphed. So summarize, it's every single x left to right except what? Except what? The asymptotes. Every x except the asymptotes. So what I'm going to do is I'm going to say x does not equal the asymptotes. I'm not going to write the asymptotes, but yeah, the asymptotes, which were k pi, where k is an integer. So the domain and the asymptotes are related to each other. All right? Try the next one.
I gotta look, I forget now. I would never let it. Yeah, I don't. You do it all. Like what's here? Wait, yeah. Yeah. It's easier for me to do it visually, like when I'm walking down, but yeah.
Just a reminder, if we have something like minus subtract pi, that's horizontal, that's on the inside, right? Do I do minus pi in my table? We always do the opposite operation. So if you did minus pi in your table, it's wrong. So I have my table and my graph up here. So when you've gotten to your table and your graph, check it, and we'll go over the answers for the blanks in just a moment. If you want to check your table before you graph it all, my table's up there. That's what I was checking. You're going to subtract. Other than that, yeah. Oh, it's like negative. Yeah. You didn't multiply by negative. Well, that's a bummer. Good. So if you guys have your table correct, then your graph should be correct. Some people are just take a little bit longer to graph it, but I want to make sure we get to the last question. So we did not have a horizontal stretch or shrink. So 2 pi would still be our period. Did we have a phase shift?
Yes.
We did. And you write the direction. So right pi to the right pi. And then did we have a vertical shift? We did not. So none. And then your domain and your asymptotes are basically the same. You just, for domain, say x does not equal. So it's everything except where x is pi over 2 plus k pi, where k is an integer. And then your range is going to be 2 pieces that go from negative infinity to negative 2 bracket, union that with 2 to positive infinity. And then we have to attempt to do this last one in our last couple minutes. Those seem pretty easy. Would you say, agree? Especially because we've been doing these transformations for a while. Let me get you started on this one, and then of course I'll jump in and make sure that you're doing it right before you do it all wrong.
Yeah.
It's like very,
That's more like.
it's higher than 2. If you're still filling out the previous one, you can get that from me. I need you to try the last one before you leave today. So skip to the last one. All right, so you went and you said this is secant. Well, that's cosine. So I'm going to put my cosine values. And I'm going to flip them to get my secant values. Then we're going to look at transformation. And the 1/2 is a what? It's a horizontal stretch by a factor of 2. So you're going to take your x's and multiply those by 2. And then you're going to look at the pi. And you're going to tell me what to do with that pi. So subtract pi is not the correct answer. We have to factor, thank you, those of you that noticed it and remembered that rule, we have to factor out the 1/2. So we actually have secant 1/2 parenthesis x plus 2 pi. 2 pi. So now horizontally, what are we going to do with the 2 pi? Subtract 2 pi. So that negative pi and that positive pi, those are asymptotes. And those asymptotes are how far apart? 2 pi apart. So I'm going to actually just go down and write my asymptotes right now. X equals, the first one's at pi, and we're adding 2 pi each time, so I'll write 2k pi or 2 pi k, where k is an integer. Because they're 2 pi apart. This seems wider than the other one. Oh no. Because we had a horizontal stretch, that makes our period not 2 pi anymore. Yep. So whatever you did for your horizontal stretch, you do to the period as well. Now the period is 4 pi. I'm going to put up the rest of the answers and pass out your worksheet. So you should be trying to figure these out. I have them up posted as well at the time. Make sure those don't hurt. And reminding you that everybody should be working equally on this project. So if somebody new joined your group, maybe you guys want to discuss their participating parts of the group, or if one person took it home and did all the equations over the weekend, maybe you're going to discuss what the other person's now going to do and how they're going to add on some equations as well. When you present, my question might be, which equations were yours? And again, due date changed to not this week. Next. You will have some. So hopefully some on Blockdate and definitely some on Friday. As far as I know. Somebody asked me that earlier and I was like, I hope so, because that's what I'm planning on.